Alright, welcome to the ultimate PC part selection guide. So I am assuming that you want to build a PC and you need to choose PC parts. And if that's the case, then you've come to the right video because we're going to go over exactly that. And by the end of this video, you are going to be very well informed on how to choose the PC parts to get the optimal build for your budget, for performance, and for your use cases. So I'm going to assume that anyone watching this video is going to fall into three categories. And those will be gaming, development, and creation. So gaming, you're probably caring about, having a high FPS, having good 4K resolution, and having fast, low latency gaming experience. For developers, you are working in IDE and you have to compile things maybe, or you're doing some sort of web development, stuff like that. And for creators, you're streaming, you're recording, you're working in things like Photoshop or Blender or Maya, other creation softwares. And maybe you're any of these, maybe you're all of these. I know I certainly am. If you're just a web surfer, then I would question why are you building a PC maybe. But I think hopefully most people will fall into these categories. And I'm also going to give you guys a 10-step method. And this is a method I came up with that I think is pretty foolproof. So this should last throughout all of time. It should be pretty timeless, and it should be very reliable so that anyone with any use case can follow my 10-step method and end up picking really solid PC parts that are optimal for their build. I'm not going to be covering overclocking, so if you know what that is, then there's a ton of other videos out there covering that. And if you don't know what that is, don't worry. And I'm not going to be covering making a server machine, so that's just a very niche case that would have its own video all to itself. And I'm not going to be covering how to physically build a PC, so like how to assemble, how to connect the wires, stuff like that. Linus has a really great video for that. And lastly, I'm not going to be marketing you specific parts. So this isn't a paid video or anything. I'm not going to say, oh, buy Intel's i7 1370 or something like that. I'm just going to give you the information so that you can make a very well-informed decision on your parts for your use case. So basically in this video, I'm going to start by going over a very brief guide of how a computer works. And don't worry, this isn't going to be too deep or too lecture based. It's just going to be, I'm going to give you the relevant information you need to know so that you can go forward and look at the specs of all the different components and feel confident that you know how these specs are going to affect the performance of your build. Then we're going to go into a deep dive of all the major components in a PC, and we're going to look at how the market works and the specs that you need to care about, and like how those specs contribute to different aspects, like if you're a gamer, a creator, or a developer. And then after we've covered all these parts, I'm going to give you guys my 10-step method of how to pick the parts for a PC, which I think will be pretty foolproof and it'll be pretty generalized to any use case. And then at the very end, I'm going to give you guys some current market advice for just things to avoid, types of specs you want to care about or look for, and based on how the market is going right now. Okay, so how does a computer work? If you think you already know and you pretty much already know what all the components do and stuff like that, you can skip this section, but I would say that it'd be nice for all of us to be on the same page, and you might learn a thing or two. So I'm just going to go over this very briefly. So if you don't already know, a computer is an assembly, a PC specifically, is an assembly of about 8, give or take, parts. And it's a really ingenious system the way they did it, so that you can kind of connect different types of parts from even different manufacturers together and assemble a completely unique PC. And so each of these components kind of has their own role. So the CPU, which is the central processing unit, is the main brains of the computer. This is kind of, at a fundamental level, this is what a computer actually is. And the CPU is in charge of basically running all your processes, like Chrome and YouTube is how you're watching this video, and running the game on the main thread and stuff like that. And basically it exchanges data with other components in the PC to execute all the processes. But the CPU is like the lead, the master of the computer. It kind of does all the main work. And it also has a cache, which will come up in a second, but cache is like a small amount of memory, which is important to consider. So the CPU has this very small amount of memory in it that it uses to do small little computations. So next we have RAM, which stands for random access memory, but most people just refer to it as memory. And the memory is like the working space for the CPU. So cache is very small in the CPU, but it's very fast. It's on the order of a couple of megabytes. RAM is a lot larger, maybe like 8 to 16 gigabytes of RAM, but it's slower than cache. So the RAM is important because the RAM is where all the applications get loaded into, and it's where a lot of data is stored while you're using your computer. And then storage is the slowest, so we'll talk about that in a second. But the RAM is kind of in the middle there. It's the middle amount of size and speed. Okay, so next up we have the GPU, which is the graphics processing unit. Some people just call it graphics or graphics card or video card or VGA. You'll hear it called a lot of different names, but it is in charge of creating the display image. So the CPU will send data to the GPU saying like, here's some text I want you to show on the screen, but the GPU is actually in charge of converting the data it got from the CPU into literal pixels that then get sent to your monitor so for you to see. So the GPU is basically, its sole job is to make that display. But importantly, the GPU is like a peripheral device. You could technically turn your computer on without the GPU. It's just a peripheral that allows us to see a screen, which is like the way we interact with the computer. So next up we have storage, and you'll hear it called disk or hard drive. And the job of the storage is to basically store permanent memory. So it's the slowest form of memory compared to like cache and RAM, but it's the only permanent form. So when you turn your computer off, everything in the cache and the RAM disappears. But everything in storage will stay. And so that's where you have the operating system, all your applications, and all your files, stuff like your photos, your games. That's all stored permanently in the memory, in the storage. And then in runtime, so while your computer's on, some of those applications and files will get loaded into RAM to be used by the CPU. So next up we have CPU coolers, and they're just usually a term called cooler. And basically the CPU gets very hot. It is this tiny little rectangle, and it is doing a ton of calculations, and there's a ton of power going through it. So it can get up to 100 degrees Celsius, which is burning hot. I mean, you couldn't even touch that probably. And so we need to have a cooler that will try to pull heat out of the CPU, because if you just have the CPU running without the cooler, and it gets too hot, it'll start to damage itself. And there's two kind of categories of CPU coolers. There's liquid coolers and air coolers. So liquid coolers remove heat with liquid, but air coolers conduct heat into a radiator that removes it from air. Next up we have the motherboard. So the motherboard is kind of the hub of the entire computer, and its job is to route all the connections from the CPU to all the other components. So the GPU, the storage, the RAM, they all talk to the CPU through the motherboard. The motherboard also is in charge of regulating the case fans. It's also usually in charge of Wi-Fi or Ethernet, and I/O, which stands for input/output. So things like USBs, aux jacks, stuff like that. And it also typically has like a couple extra features that we'll talk about later. So next up we have the power supply unit, which is abbreviated just PSU, or just power. And it's got a pretty self-explanatory job. It just powers all the components. So all the components draw a certain amount of power, and you just got to make sure that your PSU provides enough power, and it just plugs into the wall outlet or wherever you power your device. And another important thing is it does protect against like power surges or like outages, so that your PC can be safe even if it's in the middle of doing something important and your PC just goes out. And then lastly we have the case. So the case encloses and protects all the components. It's sort of like the shell of your computer, and typically there's some front I/O, so like there's some USB ports next to like the power button and stuff on the front of your case, and then there's typically case fans. So those are either already pre-installed, or they already come with the case, or you buy them separately and then install them into the case, and those just regulate airflow throughout the entire computer to keep everything nice and cool. And typically cases also have like a style to them, so you can pay more for like the RGB LEDs and stuff like that to have your case look cool. And so then I wanted to quickly show two examples of a PC so that I can just point out these components so we can get a really clear picture of what we're looking at here, what we're going to build. So here's the big motherboard. You can see this big rectangular board that takes up kind of the majority of the case. And the motherboard typically always sits in kind of this top left corner, and it always usually has this orientation, depending on your form factor and stuff. But so this is the motherboard, and then this right here is the CPU fan. So this is sitting on top of the CPU. So underneath this fan, there's the CPU, and it's just this little square mounted into the motherboard, and this is cooling that CPU. Now here are your two RAM sticks. So we can't really see them that well because they're vertically inserted, but those are the two RAM sticks that talk to the CPU. And then here's a case fan, and then there's probably 3 case fans mounted in here that are pulling air in through the case, and then that air is going through all the components, and then this fan is probably exhausting air. Here is your GPU. It's also vertical relative to us, so we can't get a good look at it, but this is doing all the video display stuff, and it's getting powered, and here's the motherboard power, and those are all connecting to down here where the power supply unit is hidden away. And then on the back of this case is where all the I/O is. So if you can see these silver things, these are like USB headers and Ethernet headers that we can plug into in the back of the computer. And then for the graphics card, there's also HDMI ports on the back here. So and then lastly, there's probably some front I/O up here. There's probably some USB ports, and the power button's up here. And then one more example. So this is a liquid cooled system. So whereas this was an air cooler cooling the CPU, this is a liquid cooled system. And again, here's that motherboard. This is a bit of a larger case. Here we can see the power supply unit. And then, you have here we see 4 RAM sticks. So before we had only 2 RAM sticks, but you see there's 2 other slots that they weren't inserted in. Here we have 4 RAM sticks. And again, so here's our liquid cooler. This is a radiator that the liquid cooler connects to, which we'll go in detail more. Here's our GPU right here. Here's some case fans. And these are actually some storage SSDs. So we didn't see that before, but sometimes the case will have cages for different storage devices. Okay, so now that we have an understanding of how a computer works, we're going to go through the notable specs of each component, and we're going to talk about the importance to the 3 major categories of gamers, developers, and creators. And then we're going to talk about who manufactures these components, and we're going to give you a market breakdown of how the component works in the market. So, first up, we're going to start with the CPU. And there's a couple notable specs that we have to care about with the CPU, and we're going to go through each of these. So, for clock speed, this is measured as a frequency in gigahertz. And clock speed is kind of just the general speed of the CPU. So, the frequency itself, the clock speed itself, isn't super important. It really is IPS, which stands for instructions per second. And that's sort of like the raw, like how many instructions the computer can execute, basically how fast that will work. And that's really just the speed of one core. So we'll talk about cores in a second. But so the takeaway is that clock speed is basically, as the name suggests, the speed of the CPU. And so a higher speed leads to more performance, but also usually more heat, which we'll also talk about. So what does it do with these cores, though? Because clock speed isn't the full picture. So cores and threads, they're each kind of like a mini computer, is a way you could think about it. So each core can run threads, and threads run processes. So processes are kind of like, you can think of like the different things like apps. So you can run more apps with more processes. You can run more Chrome tabs. You can run a game at the same time that you're recording it and stuff like that. Those will all do with having multiple processes. So having more cores typically leads to a higher total IPS because, if each core, if you have say 4 cores and each of them has an IPS of say 10, then you can have a total of 40 IPS because you just kind of multiply the IPS by the cores. But that's not really the whole picture because any single application, like say a game, typically only runs on 1 or 2 threads. So even if you had like say 1,000 cores, which is impossible, but say you did, you still wouldn't really get a benefit if you only were using an application that ran on say 1 or 2 threads. And a thread is kind of like just a virtualized core. You can just think of it as pretty similar, but the takeaway is like more cores and threads is typically better. But also, don't get confused that you might think, oh, well, I'm going to play like a video game and I'm going to close down all my other applications so that I'm only using one thread. That is not how that works. If you don't believe me, just open up Task Manager right now on your computer and you'll see that there's tons of other background processes that are all happening at the same time. And some of them are even pretty significant processes. And so multi-core will tend to increase your performance, even if you think you're only using one app or something like that. And even some games or programs will use multiple threads at once. So really, cores and clock speed do both factor into total performance of the CPU. So now moving away from just kind of raw performance, another big factor is integrated graphics. So integrated graphics are basically a way to talk or connect to a display without having to have a GPU. So it's kind of like having a really bad GPU inside of your CPU. And yeah, it's not like a viable option. Like if you're gonna do gaming, you're gonna get horrible FPS and you're gonna have horrible resolution if you try to use integrated graphics. But it can have its conveniences. So for example, if you're gonna use a dual monitor setup, you can plug one monitor into the GPU, and that could be what you do like gaming or like more heavy application stuff on. And then your other monitor you could plug into the CPU. Just make sure you're not like doing the gaming on that monitor. And then you can also do things like build troubleshooting. So say you're worried that you have an incompatible GPU while you're building your computer. Well, you have no way to know what part is bringing your computer down because you can't even get a display. You can't even see the BIOS because there's nothing to show the graphics for your display. But if you had integrated graphics, you could temporarily plug your display into your CPU and see what's happening maybe. And then, if you can get a display to result on your CPU, you'll know that the GPU must be the issue. And also just generally, if your GPU fails, so, if you're using your PC and your GPU just for one day just croaks, you're kind of out of luck because you can't really use your computer without seeing the display. But if you have integrated graphics, you can switch that HDMI cable into your CPU and still temporarily use your computer enough to before you get a new GPU or something like that. But in general, I would never recommend buying or building a PC that had no GPU at all and just only relying on integrated graphics unless you really know what you're doing because they're typically always much weaker than a real GPU. So next up is TDP, or Thermal Designed Power. And you'll see the spec come up a lot actually because it's pretty much has to apply to every component. And so thermal designed power just means how much electrical power that component, and in our case the CPU, consumes. And this is measured in watts. And so typically the higher the clock speed, you're going to have a larger TDP. And if you're all about performance, you don't care about anything else, then it's okay to sacrifice and have a really large TDP. But if you're someone that pays the electrical bills, then you might want to be a little bit more energy efficient here because the amount of power consumed by a computer is no joke. I mean, if you look here, like a phone charger consumes like maybe 5 watts, whereas like just the i7-13700K alone, just the CPU consumes 125 watts, and you can easily get up to like 850 watt total power for your PC. So yeah, power is a consideration, but again, if you are going for performance, you're probably going to have to just make a sacrifice for power. All right, so next up, we have memory and PCIe support. So the CPU, like I said, talks to all the other components in your computer. And so there's certain constraints that the CPU imposes on how fast and how much it can talk to these other components. So for the memory or for the RAM, um, there's a max speed that the CPU can talk to the RAM. So your RAM will have a speed, which is measured in MTS, which is megatransfers per second, and the CPU will have a max speed it can talk to that RAM. So this is important to consider because you don't want to buy this really fast RAM that does say 8,000 megatransfers per second, but your CPU can only handle up to a max speed of say 5,000. Like that'd be a waste of buying that really expensive RAM if your CPU can't even go to those really performance speeds. Same with max size. So maybe your CPU can only handle max of 64 gigs of RAM, so don't buy 128 gigs. And then number of channels. So typically it supports dual channel. So don't buy quad channel if your CPU can't support up to those number of channels. And this will make more sense when we get into RAM too. So don't worry if you didn't really pick up on all these stats, but just know that you do have to check the memory constraints of the CPU. And then for PCIe, PCIe stands for Peripheral Component Interconnect, and PCIe is basically the way that the CPU talks to other peripheral devices, such as the GPU, storage, or like a network card. The E here stands for Express because PCIe is like a newer version of the original PCI. And so inside of the PCIe, there's different generations. So like 1, 2, 3, 4, 5, and then in the future we'll probably make 6, 7, 8, and so on. And the greater the generations, like Gen 5 is faster than Gen 4, and same with Gen 4 being faster than Gen 3. So your CPU will typically only support, say, up to Gen 5. And then also PCIe has a number of lanes. So PCIe, you can think of it like a ton of little wires. And so the more wires you have, the more data you can transfer between the peripheral component and your CPU. And most CPUs support up to 20 lanes. And that's because the GPU typically takes up 16 lanes, and your storage device, like your SSD, typically takes up 4. So, like, if you're going to do that, don't get a Wi-Fi card additionally that takes up, let's say, another 4, because that means that 2 of your components are going to be sharing PCIe lanes, and that will make them less performant. So already you might be thinking like, okay, if I get 2 GPUs, then those both take up 16. I'm not going to have enough space. That means my GPUs are going to be sharing PCIe lanes, and that's one of the main reasons why people say don't get 2 GPUs, because you're not going to double your performance, because these 2 GPUs have to share their lanes, which will significantly reduce the performance of the second GPU. So next, moving on, we have socket type. So the socket type is basically the physical connection that the CPU makes with the motherboard. So there's 2 main types, PGA and LGA. So you can see in PGA, there's all these little pins that stick out of the CPU, and those will go into a bunch of little holes on the motherboard, and you have to insert these pins into the motherboard in a very specific way. With LGA, there's a bunch of pads on the CPU, and the motherboard has a bunch of pins that stick up out of it, and these pins touch the pads on the CPU. So typically LGA is associated with Intel and PGA with AMD, but there have been like some Intel PGAs and whatnot. So and then inside these 2 categories, like there's LGA 1700, LGA 1400. There's a bunch of different types of categories. So basically, just make sure that you're looking at what socket type it is, because each motherboard only supports a specific socket type, because the CPU has to make that physical connection to connect into the motherboard. So it has to be specific to what socket that CPU is. So now I just want to show you guys real quick what the motherboard looks like, so you can see how that socket works. So here is a PGA socket for the CPU to go into. So this would probably be an AMD motherboard, and you can see, I don't know if you can see this very well on YouTube, but there's a ton of little holes in here for the pins of the CPU to go into. And then this is typically probably an AMD or sorry, an Intel motherboard, because there's a ton of pins sticking up here that touch the pads of that LGA CPU. And also, just typically, Intel CPUs typically have, or sorry, Intel motherboards have this sort of holder for the CPU that has this like big metal pin that comes out. So this is typically what Intel motherboards look like, and this is more to speed with what AMD motherboards look like. So next we're going to talk about the manufacturers of CPUs. So you probably already know this, but there's two big competitors, Intel and AMD. And you probably heard like blue team versus red team. So yeah, Intel's the blue guys, AMD's the red guys. And we'll start with Intel and go over. So Intel has this brand called Core, which is basically all their CPUs. They have a couple other CPUs, but for the most part, everyone just focuses on Core. So Intel Core is always like the prefix of the name. And then you have the series modifier. So there's 4 types of series. There's the i3, 5, 7, and 9. And these are kind of the tiers of the kind of performance and capabilities of the CPU. And there's also the generation. So there's 13 generations, and these increase with time. So when Intel made their first CPU, it was, Gen 1. And at this point, we're up to 13, but in the future, I'm sure we'll have 14 and 15 and so on. So generations increase with time, but for each generation, there is 4 different types of CPUs in that generation, and those correspond to the 4 series. And the series are kind of like basically your price tiering options inside of each generation. So you're typically always going to want to get a relatively recent generation, like coming out of this video, probably either 13, 12, or maybe 11. But in those generations, you're going to want to pick based on your build. If you're getting a cheap end build, maybe you get an i3, and if you're getting a really expensive build, you get an i9. And then inside of a single generation and series, you might have still multiple CPUs. So those will be distinguished by that second part of this number. So here's the generation number, and here's the just kind of SKU, or just like specific model number. And then there's also going to be suffixes. And so you'll see this is the same with AMD. We're going to have different types of suffixes, and you can look up, this is not a full table, but you can look up the full table. And so like K stands for high performance. F means that there's no integrated graphics. X or XE typically means the highest performance. So like the best CPU is a 13th gen i9X suffix, whereas like the worst GPU or the worst CPU is like a Gen 1 i3, and like those probably aren't even sold anymore, but that's kind of the spectrum of Intel CPUs. So next for AMD, they pretty much do the same thing as Intel. So we have this Ryzen brand, which is pretty much what all of the AMD CPUs fall under. And then they also have a generation system, but it goes from 1,000 to 7,000. So 1,000 being the earliest, 7,000 being the latest, and maybe the time you're watching this video, they're already up to 8,000 or 9,000 or whatever. And they have 4 types very similar to Intel. So they have 3, 5, 7, and 9, which are kind of like the same tiering systems. So the other thing to note is that AMD has this second number after the generation. So this, for example, this product is in the 3000 generation, but then 6 kind of indicates the performance level within that generation on top of the series indicating the performance level. So it's kind of can get confusing, but basically the best AMD processor would be like the highest CPU generation, the highest performance level, and the highest kind of series of that generation. And then AMD also has their suffixes, so like G is for integrated graphics, X is for the higher clocked processor, H is for high performance mobile. So like if you're building a PC build, you probably don't want to get an H processor. And you can see a full list of this on AMD's website. So lastly, just the advice I have for people looking for your CPU for the different categories. So for gamers, clock speed is most important because a game typically won't run on more than 2 or 3 threads max, maybe only 1. So to get the highest FPS, to get the best resolution and the fastest, the lowest latency, the fastest input and all that, clock speed is your main factor. Number of cores and threads, not super relevant. I mean, if you're streaming, if you're doing other multitasking things, maybe you do want to increase that a little bit and have a better balance, but typically clock speed is where you want to put your money into. For developers, you really want to balance because both having increased core count and clock speed will both contribute to things like compile time. And for raw clock speed, that'll just speed up the performance of development, things like IntelliSense. But for core count, you're typically going to be multitasking as a developer. You'll have your IDE open as well as probably Stack Overflow or whatever other software you're using to aid development. And so you really just want to strike a good overall balance of your CPU. And then for creators, typically core count is more important because you're going to be multitasking. You might be streaming and using all these different systems, all these different softwares all at once. Speed is more of a convenience because you're probably not doing something that requires immediate speed, requires a lot of performance, but typically you want more just stable multitasking. And in general, having a balance of these two, cores and speed, isn't a bad idea, but this is kind of the split for the different categories. As far as the other specs like TDP, that's kind of a general spec. Like if you want to have more performance, you're just going to sacrifice by drawing more power, running up your electricity bill. Integrated graphics, I would say, is not really that important for gamers because you're definitely going to have a GPU. But as a developer or creator, if you're doing dual monitor, stuff like that, you might want to care about integrated graphics. And then all the other specs will be pretty much specific to the other components that we get into. Alright, so next up we have CPU cooler. So there's two types of coolers, liquid and air. And the main difference, they're actually way more similar than you think. But so air coolers basically have this plate where they conduct heat from the CPU and then spread it through these metal arms into this big metal radiator. And then fans just blow the heat through the radiator and out of your entire case, basically. Liquid coolers, on the other hand, have a similar plate that they stick onto the CPU that pulls that heat away from the CPU, but then they conduct that heat into water, and then they have a pump that pushes that water away from the entire operation into another metal radiator that's kind of farther away. So basically, the only difference is here we have the heat just going through these metal arms to a very close radiator, whereas here we have the heat going through water to a radiator that is far away. And then again, you have fans just blowing the heat through that radiator. So they both have a radiator, and they both have fans, and they both have a heat plate that is going to be pulling that heat off the CPU. So the important specs to note here are fan CFM, which is cubic feet per minute, and this basically determines how much total air the fan can move. So if a fan has a larger CFM, it can just move more air, basically. The longevity or the lifetime of your fans and your cooler is important, so you don't want a cooler that's going to fail on you after a year. Then radiator size, so for air coolers, there's going to be different kind of dimensions and specs for that than liquid coolers, but obviously a bigger radiator means you can dissipate more heat and cool more effectively. And then heatsink material, so copper, if you see it's a copper heatsink, that's going to be a lot better than an aluminum heatsink. And the noise level of your fans is very important. So if you're doing stuff like recording, or even just if you're not recording, but you think, noise level probably won't be that important, but it can just be really annoying if your fans are very loud. And if you're recording, it can be just impossible to record because your fans just block your voice even. So bearings also contribute to that noise level. And then just it has to support the socket type. So most CPU fans are only built for a specific type of socket or a specific range of sockets. So obviously you need to make sure that your fan is compatible with the CPU you picked. And then build dimensions. So maybe your CPU fan won't fit in your case, or it won't fit next to your RAM, stuff like that. We have to consider these things, and we'll go over in more detail how that works. But so typically the CPU fans are going to be, or sorry, the CPU liquid coolers are going to be the higher end coolers, and just the air fan coolers are going to be the lower end coolers. So let's look at that in a case. So here is a air cooler in a case, and you can see what I mean by support for the case dimensions. So this fan barely makes it in this case. You can see if it was any bigger, if the case was any thinner, it might be sticking out. You wouldn't even be able to put the glass back on. And that's typically the problem with air coolers, whereas with liquid coolers, it's about like the side and front mounts. And you can see like this fan is so big. I mean, look at the clearance between the GPU and the fan. There's like barely any clearance. So you have to make sure all these measurements are taken care of so that you don't have any incompatibility issues. And then for liquid coolers, it's about where you put this big radiator. So you can either put it on the front or on the top of your computer. And so just making sure that that your CPU fan radiator has the proper length and dimensions to fit in the case, and also that your CPU cooler doesn't protrude into the RAM. So like some CPU coolers are so big that they might block your RAM if you have a certain type of motherboard. So yeah, some advice for picking a CPU cooler is to match your CPU's performance and your overall build tier. So don't buy a $1,000 CPU, the most insane like Threadripper or whatever you can find on the market, and then buy like a $25 CPU cooler. You are going to just kill your CPU. It's going to overheat. It's not going to be worth it, and it's just a waste of all that money. So don't try to think you can skimp out and buy a super cheap CPU cooler if you're already going to spec into an extremely pricey CPU. And then same on the other hand, don't buy a $200 CPU and then buy like a $250 CPU cooler. Like that doesn't make any sense, because cooling is not going to be the limiting factor of your machine. You could probably have bought a way more expensive CPU for that price tier. So just match your CPU's performance and match your overall build tier that you're going for. Also, just don't ever buy like the cheapest liquid cooler. Like typically liquid coolers are higher end, so typically air coolers kind of dominate in the range of like anywhere from like $20 to like $100 maybe. And then after $100, you're probably going to want to just spec into a liquid cooler. But don't buy like a $70 liquid cooler, because it's probably going to be pretty low quality. It's probably not going to have a good lifetime. And the fact that that manufacturer made such a cheap liquid cooler means they're probably hiding some bad specs about it. So yeah, I would, if you're going to go liquid, then you should already be looking at like say a $1,500 or greater PC build. And you're going to want to spend probably at least $100 on that liquid cooler to get just a good quality liquid cooler. Also, obviously, just check build dimensions. I kind of already went over that, but the last thing you want to do is end up buying a CPU cooler that just doesn't fit in your case or whatever. So, yeah, that's my advice for CPU coolers. The main goal of a CPU cooler is just to be reliable, right? I mean, it doesn't really affect performance besides just bottlenecking your CPU if it's not good enough. So you just want a good, reliable, and performance CPU cooler to just keep everything nice and steady and cool. Alright, so now we're going to get into RAM, or random access memory. So there's a couple important specs that you want to consider when looking at picking your RAM. So the first one is size, and this is kind of a no-brainer. The more size, the more gigabytes of RAM you have, the more room your CPU will have for storing applications, and it'll load more of your operating system into the RAM, and it'll just work faster, and you'll be able to run more operations, more applications concurrently. So especially like if you're multitasking, more RAM means more Chrome tabs, more apps, more stuff like that all at the same time. Clock speed is another kind of obvious stat. So this just affects the raw speed of your RAM, and this is correlated to basically how fast your RAM can deliver information to your CPU, which is basically the main important speed stat, or the main performance stat. But it's not the full story. And then first we're going to talk about in depth the DDR version. So DDR stands for double data rate, and over the years we've created newer versions of DDR. So lately we've just created DDR4, and I believe DDR5, we created that in 2020. And in a couple, maybe, I don't know, 5 or 10 years, they'll come out with DDR6. Maybe they already have it by the time you're watching this video. And in the past, we had DDR4 and DDR3 and so on. And so you'll see here that the clock speed increases with each DDR version. So with DDR3 had a very low clock speed, and we're up to DDR5, which has a very high clock speed, and we haven't reached this top level yet. But we're making more and more RAM sticks that are more fast and having like faster clock speeds. But that's not the full story. There's also this cast latency, and this determines how fast in nanoseconds the CPU or the RAM can fetch a piece of information and deliver it back. So we actually have to take into account both the cast latency and the clock speed together to find the effective speed of the RAM. And you'll notice that cast latency increases with DDR version, and this is bad. Latency is like basically delay, so you don't want to have higher latency. So there's a trade-off going on here that we're going to investigate with first word latency. But obviously, before I talk about that, I just want to say that each DDR version has a different socket type. So motherboards will be DDR version specific. So if your motherboard is a DDR4 compatible, you couldn't put a DDR5 RAM stick in there. So now let's talk about first word latency. So this combines cast latency and frequency, and it's pretty much the best speed indicator. So here's the formula. If you go on PC Part Picker, this will be already calculated for you. But here you're doing first word latency, or just kind of overall latency, is equal to 2,000 times the cast latency divided by the frequency. And this will give you basically the effective number of transfers that your RAM can do per second. So that's just how fast your RAM can deliver memory to the CPU. Next, we have number of channels, or rank. So remember the idea of multi-cores for CPUs, having multiple cores. This is similar to having dual rank or quad rank, and the idea here is that you can have sort of multiple RAM sticks running in parallel, and that effectively makes the RAM sticks one big RAM stick. So if you had two, say, 32 gig RAM sticks and they're dual channel, that effectively makes them one 64 gig RAM stick, and you can deliver more information to the CPU with dual rank or quad rank or whatever. Dual rank is the most common. You're probably going to get a dual rank PC, so you don't have to worry too much about making sure you pick the number of channels or the rank, because you don't really get that much freedom there. All right, so next up we're going to talk about manufacturers. So the market is very spread out. There's a ton of different manufacturers that all make their own RAM sticks, and they're not super differentiated. So like, you're not going to see any crazy new features or performance in a Viper versus like a Fury RAM stick or something like that. It really is pretty much, you're buying a RAM stick and you're picking these key stats, and that is the RAM. It's not like the companies have that much of an effect of new features or performance. But some really popular companies are Corsair, G.Skill, and Kingston. So a lot of people will say, "Oh, I only buy Corsair RAM," but just look at reviews, stuff like that, because it really is kind of a spread out market, and there's not any one dominating competitor. So my advice for gamers, honestly, 16 gigabytes is enough. So, like I said, RAM is more of a multitasking thing. When you have, for size, you really don't need more than 16 gigabytes for gamers, because game developers actually optimize to expect that your PC doesn't have a ton of RAM. They're usually not going to expect that you have 32 or 64 gigs. But speed is the most important. So you're gonna want that higher clock speed and lower latency. So you're really going to go for optimizing your first word latency. And then for developers and creators, more RAM is typically better. So, that means you can have more Chrome tabs, more applications running. You can be streaming and recording that data. You can do more stuff all at once. And so I would say up to 64 gigs, unless you really, really know you have a use case where you're going to be using more than 64 gigs of RAM. I would probably not do it. Getting 128 gigs of RAM, you probably just won't see that much of a performance increase. But yeah, up to 64 gigs, you do just want more of it. And speed is at best kind of more of a convenience because you're not going to notice that much. Like usually RAM speed is not the bottleneck factor of your computer performance. It's usually the CPU speed. So yeah, typically for developers and creators, you just want more RAM. All right, next up we have the GPU or graphics processing unit. So the graphics processing unit is composed of a bunch of different specs, but there's a couple key ones that I want to talk about. And some of the specs are actually kind of specific to the manufacturers, so we'll talk about in a second. But some common specs we'll see here. We see again TDP, which is that thermal design power. So that's just how much power the GPU draws. And let me tell you, the GPU does draw a lot of power. And then the GPU also has memory. There's also this LHR you see. Stands for low hash rate. And this just means that the GPU can't be used for crypto mining. So typically this will be a little cheaper. So unless you plan to crypto mine, maybe you would consider getting the LHR because it typically doesn't really affect any other performance other than it just brings the price down a little bit, which is a nice benefit. And then again, we'll see clock speed here, which just is kind of the raw speed of the GPU's kind of main processors. But so anyway, let's first get into CUDA cores. So I have this CUDA cores or compute units because NVIDIA and AMD do it differently. But this is similar to kind of just multi-cores in a CPU. So the more CUDA cores or the more compute units means the more things it can do at once. And when I say at once in this context, I mean the more pixels it can handle and the more things it can shade, the more calculations it can compute. So basically more is better. There's not a good way to convert the number of CUDA cores to compute units that I know of, but they're loosely kind of correlated. So AMD will boast about its compute units, whereas like NVIDIA will boast about how many CUDA cores it has. And you can think of the CUDA cores as like calculators, whereas the compute units are like clusters of calculators. Because typically you'll see like there's 10,000 CUDA cores, whereas there's only like 100 compute units. That's because the compute units are like clusters of like CUDA cores essentially. So then for memory, GPUs actually have their own memory built in, and this is a special type of memory. It's called GDDR memory, and it comes in different flavors. So GDDR5 and GDDR5X and GDDR6, sorry. And so 6 obviously is the best, 5X is better than 5, 5 is kind of the worst, but they're not super different. So like, don't scrap an entire GPU just because you saw that it had 5X instead of 6, but typically the higher ends will have the better type of memory. And then, the important specs of this are like size too, like if it has 12 gigabytes versus only 10 or 8 or something like that. And then bandwidth, which is how much data it can deliver per second, usually like in the form of like megatransfers or gigahertz or something like that. And the memory of your GPU usually affects resolution. So if you have low, slow memory, you typically can't support like 4 or 8K. So that's usually, so if you want to game on 4K or something, you typically want to get higher memory because you can store larger textures, store those 4K textures and stuff like that. Okay, I wanted to point out here the socket for the GPU. So this is what it looks like, and your GPU kind of sticks vertically into the motherboard here. And so yeah, you can just notice how like this one there's 2 GPU sockets. Here there's only 1 GPU socket, and it's that big 16 lane PCIe connector. You can see PCIe X16, and some motherboards will have like this kind of what they call like an iron clamp or something like that to support the GPU a little more. Some don't, but yeah, just note that this is where the GPU connects. So for manufacturers, there's 2 big ones again. We're again dominated by the giants, except this time it's AMD and NVIDIA. So NVIDIA's green, AMD red. And yeah, it's another kind of 2 duking it out monopoly sort of situation similar to the CPUs. So for NVIDIA, the brand is GeForce. So you'll see that GeForce before all of their products. And then there's 2 categories. There's GTX and RTX. And the RTX is typically the higher end, whereas GTX is lower end. And they also have a series similar to the series in the CPUs. So we started with the 10,000 series for NVIDIA, and now we're up to the 4,000 series. And then inside that series, there will be a hierarchy. So, and there'll be like 10, 20, 30, 40, 50, so on. So currently, like the 4090 is the newest, latest, and most powerful GPU that NVIDIA sells in the GeForce kind of brand, and the 1000 would be like the earliest, worst GPU. And then there's also variants. So this is kind of like the suffixes of CPUs. So there's typically Super and Titan, and Super is just Titan's just the more performant variant, but Super is also like a little bit more performant than the base. So you have like base, which is no suffix, Super, and then Titan being the most performant in that specific like series and category and hierarchy level. For NVIDIA as a whole, NVIDIA actually currently like really dominates the GPU market, and they typically have higher end quality. So, the peak GPUs that NVIDIA sells, like the 4090, are some of the most performant GPUs basically in the whole world. So they dominate the higher end, but they also have some really good low end options. But most NVIDIA GPUs are going to be more expensive, and that's because they promise that higher quality. For AMD, similar thing here where the brand is Radeon, and they only have kind of one category, which is RX, and they have a 5,000 to 7,000 series. So they didn't start at 1,000. They kind of do this different series thing, and because AMD also has like a ton of other types of GPUs, but most of them like really aren't for gaming and stuff. So Radeon RX is kind of the main GPU type you want to look for. And then they have variants like XT, which is kind of similar to like the Titan variant. And AMD's kind of all over the place with low end and some pretty high end GPUs. So they've recently come out with some pretty high end stuff that they're trying to compete with NVIDIA. But for low and mid tier gaming, they have a lot of really good budget options. So if you're not trying to run, 120 FPS, 4K, Ultra HD, then maybe you want a mid tier AMD GPU. You can see the similar thing where they have the generation designated by that first number, and then they have the tier within that generation, and then sometimes they will also have like an XT or something like that to indicate a variant. So my advice. So for gamers, clock speed and VRAM is important. Clock speed is the most important. VRAM and core count are kind of secondary, but you do want to spec into your GPU. In total, like overall, the GPU for a gamer is one of the most important parts in the whole computer. I say VRAM and core count are secondary because like typically VRAM isn't the limiting factor, and core count is also typically not gonna like decrease your frame rate and stuff like that much. But obviously on a really ultra HD game, you want like all these specs to be good, but clock speed is the most important of all these to just hit that really high frame rate, because clock speed is the most correlated to frame rate. For developers, GPU really isn't important. Like unless you're developing a video game, which of course, then if you're developing a video game, you kind of want to care about both of these categories because you have to test the video game as well. But if you're just developing, like if you're doing web development or just like application development or something like that, GPU is not really that important. You're not doing crazy stuff with your video display. So you can rely on integrated graphics, but like I say here, like that could sap your CPU performance. So maybe just get a really crappy GPU, and you'd be fine, right? For creators, actually core count is very important, followed by VRAM. So if you're doing things like 3D modeling, especially, and doing renders, you really care about core count. So having a lot of CUDA cores or a lot of compute units will make those renders really high quality, way faster. And you will see some benefits from clock speed, but it's secondary compared to good core counts. And, if you go on things like OpenAI, Open Blender for all their benchmarks, you'll see that the best GPUs for 3D modeling typically have better core counts. All right, so moving on, let's talk about storage. So there's two types of storage devices, SSD and HDD. And HDD is the older type, and it relies on physical components moving. It relies on an actual disk, and so it's really just obsolete technology at this point. It used to be like not too long ago that SSDs were the more expensive version, so you'd pay more, but if you're a low budget, you get an HDD. But honestly, at this point, SSDs are so cheap that I would say like HDDs are kind of obsolete, so I'm not even really going to consider them in this video. So SSD stands for solid state drive, and there's a couple key specs that we need to talk about here. So size obviously is kind of the most important. Size kind of really is the one main spec of storage, and this is measured in either gigabytes or terabytes, where terabytes are thousands of gigabytes. And so more of it is better, right? It's kind of a no-brainer. You can store more applications, more files, more photos, larger games, stuff like that. You just need more storage. Then read-write speed is also important. So that's how fast the CPU can talk to the storage. And then endurance is pretty important. That's measured in TBW, which is terabytes written. So that's like the total amount of data that can be written to the storage before it's estimated that it'll start to like kind of break down. So longer endurance obviously is better. And then form factor. So there's three main types of form factors. There's M.2, 2.5 inch, and 3.5 inch. So here we have all of them. So this is an M.2, this is a 2.5 inch, and this is a 3.5 inch. And so the M.2 factor is gonna usually be NVMe. So an M.2 stick will actually sit on the motherboard, and we'll see that in a second. Whereas these SATA connections will sit in the case somewhere. So the interface, like I say, NVMe versus SATA, NVMe is faster. So an M.2 NVMe SSD is kind of usually the fastest type of SSD, and that's because it communicates with the CPU as a peripheral through the PCIe lanes. So those PCIe lanes are very fast. They're pretty much the fastest way that anything can talk to the CPU. Whereas SATA is another type of communication protocol, which is significantly slower than the NVMe. So, this type of SSD will be slower than this one, but typically you'll find more, this one will be more expensive, and this one might hold way more storage for a better price. So that's kind of the trade-off there. So you can see here, on a typical motherboard, you'll have this heatsink right here, and so if you unscrew the screw, you can see they're kind of on most motherboards. If you unscrew the screw and take away this heatsink, there will be a place for you to put in one of these little M.2 sticks. And like in this case, for example, on this motherboard, this is probably a creator motherboard because there's a stick here for a PCIe Gen 4 SSD, and then here there's a bunch of others. There's probably like room for two more Gen 4 SSDs here. And PCIe version does matter. So having a Gen 5 PCIe SSD will be even faster than Gen 4 and obviously faster than Gen 3. But again, make sure that you have all that compatibility figured out. So to get that really fast speed for, say, Gen 5 PCIe, you need to have a Gen 5 PCIe SSD, and it has to be M.2 NVMe. You have to have a Gen 5 PCIe lanes on your motherboard to handle that speed. So like this one only has Gen 4. And you have to have a CPU that supports Gen 5, that supports the number of PCIe lanes you need so that you can run the SSD on the PCIe lanes. So a lot of information there, but just make sure all your PCIe compatibilities line up is the main takeaway. So my advice for SSDs, obviously, like I said, don't get an HDD. They're just kind of obsolete at this point. And, make sure that you do look at the generation of your PCIe support for the SSDs that you're getting for the M.2 sticks. And then you're not limited to one disk. So if you look back here, this is where those M.2 sticks go into. But on the side here, you can see these are some SATA ports. So the way that these SATA disks connect to the SSD or connect to the CPU is that they connect to this part of the motherboard through a SATA cable. And you can typically find it cheaper, but a lot more, a storage device with a lot more room on it. That's a 2.5 inch that you can connect through these SATA ports. So like for example, on the device I'm recording on right now, I have one 500 gigabyte M.2 stick, which is really fast, and I put like my operating system on that one and all my like fundamental applications. But then I have a terabyte SSD that's a 2.5 inch that's really large, but it's not super fast, and I connect that through SATA. So those combined still provide me with 1.5 terabytes of storage, which is plenty for me, and they also are a lot cheaper than if I were going to get a single M.2 stick that was 1.5 terabytes. So, you can play around with the number of disks you have and the configuration to really get an optimal price point, and as well as not compromising on speed and size. Alright, so moving on to the motherboard. Now, the motherboard is arguably the most difficult component to wrap your head around because there's just a ton of specs and a ton of features just due to the fact that it connects to pretty much every component in the PC build. But we'll try to break them all down, and hopefully you'll get a really good understanding of what you need to consider when selecting a motherboard. So, the first and just most obvious thing is that every motherboard is specific to the CPU and RAM versions. So, the CPU socket we already talked about, that is motherboard specific. So you can't just put any type of CPU into any motherboard. Your motherboard will say it supports this type of CPU. And then for RAM versions, it has to be either a DDR3 motherboard, a DDR4 motherboard, or a DDR5 motherboard. And you can't get a different type of DDR version RAM and stick that into your motherboard if it's not the same DDR version. So those two kind of specify the type of motherboard that we're looking at. And like I said, since the CPU socket types are heavily dependent on brand, where AMD has the PGA type and Intel has the LGA type, you'll typically find that a motherboard will say, oh, it's an AMD motherboard or an Intel motherboard because of those two different types of sockets. But not all Intel CPUs will fit into just an Intel motherboard because inside of the LGA type sockets, there's different types of sockets, like a 1700 or a 1400 or something like that. So just make sure that you are getting a motherboard that already has the compatibility with your CPU socket and your version of RAM. Next up, we have VRMs. We'll talk about form factor in a second, but so VRMs are voltage regulator modules. And so you'll see there are these things right here on the motherboard and also kind of behind these heat sinks. And these are in charge of delivering power to your CPU. So if you are getting a really high-end CPU that's going to be really computing a ton of stuff, then you want good VRMs. You want a lot of them. You want them to handle a high amount of current and voltage because they're going to be feeding that power into your CPU, and you want that to be nice, clean, and stable power. Jumping down here, we're going to talk about these in a second, but so fan and temperature regulation is really important because the CPU has two factors that go into that. So there's a bunch of fan headers all around here, and so you want to care about how much power these fan headers can supply and whether they're DC or PWM. That just means like how efficiently the computer can control them. And also you're going to have the number of fan headers so you can support more fans. But then also importantly, your motherboard will note that it has a specific amount of temperature sensors all around it. And these temperature sensors are placed to monitor the heat in the computer. And so the more of these you have and the higher quality they are, this will mean that your computer will get a more accurate reading of what the temperature is like inside, and that'll allow it to more accurately tell the fans what speed to run at. So those are just some important things to consider. Usually there's no one motherboard that's like really bad or really good at this. They're all pretty much similar. But it is just something to consider. Like, don't buy a case that comes with 6 fans if your motherboard only has 4 fan headers, right? Audio codec is another just kind of fun feature that you have to also consider. So there's a couple different types of audio codecs, with the later ones like the 4000 audio codecs being the higher quality. So just I would just do your own, like, if you really care about audio, like if you really want high quality audio for gaming or something like that, do your own looking into what audio codec you think you need. So just be aware that that is a motherboard feature. And then there's special features. So I'm not going to talk about all of them, but like For example, Gigabyte has their Q Flash feature, which allows you to flash the BIOS without having like a valid CPU in the motherboard and stuff like that. There's a couple other features like that that each motherboard has. It's specific to like the brand of motherboard, so you'll find that on their websites when you like read their product descriptions and stuff like that. But so now let's talk about form factor. So there's four main form factors for motherboards, and those come in order of size. So eATX is extended ATX. Then there's ATX, micro ATX, and mini ITX. So I would recommend, like, ATX is kind of the standard. Unless you really want to make a compact build where you want to go micro or mini, you're probably just going to want to stick with ATX. But if you are going really budget, or just you want to make a really compact build, you get into these two. And then again, if you're making like a really beefy build, like you want to make just the most beefy, powerful computer on the planet, then go to eATX. But typically, most people build an ATX build. Next, for PCIe support. So we already talked about how PCIe is peripheral component interconnect. I don't know why it says interface there. It stands for interconnect. And then, these are some examples of devices. So GPUs, NVMe SSDs, network cards, Wi-Fi or Ethernet cards, or both, sound cards or Thunderbolt cards, all use PCIe. Like we talked about, there's generations and lanes, and so you can see here's an example of a motherboard where, like, here's a Gen 1, or here's a 1-lane PCIe connector, so this is probably for like a Wi-Fi card. Here's a 16 lane, which is probably for a GPU. Here's another 1 lane, this could be for a sound card. This 4 lane could be for like a storage device or maybe a sound card. I don't think there's many devices that use an 8 lane long. And then these are not express, these are PCI lanes. These are very old. You'd probably never find that in a motherboard today. So then for connectivity, so the connectivity includes all your I/O stuff. So there's two types of I/O, front and rear. So this is a rear I/O. So you can see this is where the rear I/O is located. This will stick out the back of your computer. Obviously, that's why it's called the rear. This is what it looks like from like a head-on view. So typically you'll have for I/O, you'll have all your USB types. So that's Gen 1, 1.2, going all the way up to like Gen 3.2. There's tons of different differentiations for USB types. Usually you can just tell like just the higher generation and the more like numbers and stuff it has, the better it is. But unless you really, really know, like you're doing USB stuff, you're probably fine with like Gen 2 or 1. And all motherboards will probably have at least one like Gen 3 port or something. And for things like mouse and keyboard, you actually really don't really even need more than Gen 1. So people think they need like, a Gen 3.2 USB header for their mouse and keyboard, but those devices don't even run past like Gen 1 pretty much. It's really only for things like external microphones and stuff like that where you'd want to get into higher quality USB headers. And then USB-C, that can be important for things like if you're doing Thunderbolt, which I won't explain here, but you can look into Thunderbolt. There's a lot of good advantages to that. And then you have audio jacks, so you probably want at least one audio jack, or maybe you want to support, like, say, this older version of audio. SPDIF is like an older version of audio as well. So just consider like what audio you want to do. And then typically if you have integrated graphics, then your rear I/O will support that in some form. So like you'll have an HDMI port and maybe a display port that your integrated graphics from your CPU can be connected to. So here, if you want to run like a monitor off your integrated graphics, you'd plug it into the rear I/O's display port, not the GPU's connection. And then an RJ45 port is like an Ethernet port. So like you can see, there's two of them here. That would be where you would plug your Ethernet, and then if your if your motherboard has built-in Ethernet support, then you'll see one of these on the rear I/O. And then there's also front I/O. So I don't have it displayed here, but basically there's headers along the motherboard that will have connectors that you can plug into your case. So like, for example, this is probably a USB 3 header connector, or maybe this one's a C maybe this one's USB-C, maybe this one is a USB 3. I'm not exactly sure, but so these would connect to your case, and your case would have those exposed right next to the power button. So whereas these are in the back of your computer. All right, so for network support, there's a couple just considerations you want to think about. So first is just Wi-Fi and or Ethernet. So do you want your motherboard to have built-in Wi-Fi? Like, are you going to need that? Or are you always going to be using Ethernet? Because obviously you probably know this, but Ethernet is the faster, more efficient method. But in a house or in a room where you don't have good Ethernet, you don't even have access to Ethernet, you might need to choose Wi-Fi. So you need to consider like where you're going to be using your PC. And then for the version for Wi-Fi, there's 5, 6, and 6E. So with each generation or version, you get more speed and stuff like that. 6E actually operates on another band too. So if you're using your PC in a very congested network, then maybe you want 6E, but you're probably not. You're probably just using it at your house or something like that. And then just bandwidth is just how many gigabytes per second you can transfer. So higher bandwidth means you can do more stuff, but you're also limited by the bandwidth of your router. So there's a lot of considerations. You probably aren't going to go wrong with like a decent built-in Wi-Fi or Ethernet, but you do just want to get like that higher, like 10 gigabits per second being like the max rate you can transfer. So yeah, just consider it's really what you want for networking options. And you can get, so I didn't talk about this as a component, but you can get a Wi-Fi or Ethernet card, which would plug into like one of these PCIe slots. And then like that's an external device that will support the Wi-Fi or Ethernet or whatever you want. I don't recommend that just because honestly, motherboards with built-in Wi-Fi or Ethernet are not that much more expensive than if you were to have to buy a Wi-Fi card separate and then buy a motherboard separate. That actually might be the more expensive option. So it's really just efficient to just get the network support with a motherboard that already comes with it. And most motherboards will at least support Ethernet. And just for your awareness, so typically this device right here, this shield, is covering like the Ethernet or the Wi-Fi support. Like this is where the Wi-Fi or Ethernet is processed. And if you saw a motherboard that didn't have this, then it probably doesn't support networking, and you have to get an external network card. And then these here are probably where you would connect the antennas for the Wi-Fi. Okay, so now let's look at the motherboard market. So there's 4 major companies that kind of dominate the market, and those are Asus, MSI, Gigabyte, and ASRock. So you will see some other small companies, but most motherboards will come from these 4. And for naming conventions, for Intel motherboards, there will be H, B, and Z prefixes. So H is like lower end, it stands for like home or consumer. And B is like your mid-range, that technically stands for business. And then Z is like extreme or like max performance kind of. So they go in range of performance. And then for AMD, there's A, B, and X. So A is like consumer or home, and B is also mid-range, and then X is like extreme or max performance. So you can see here like this is a AMD motherboard, and you can see it's X here, X570. Here's an MSI motherboard, also AMD. It's got the B550, so it's mid-range. Here's an Intel motherboard, and you can see it's Z590, so it's like the extreme or max quality because of the Z here. And then here's an H670, so that's also an Intel, and the H means it's like the lowest tier. And then there's also the actual series, or like the 3-digit number that comes after it. So like you have here like 570 or 550, 590, 670. And so these generally indicate kind of like the generation or the series of the motherboard. So with higher numbers being better and later. And these also typically indicate the like performance of the memory controller and just other features. So like the higher that number generally means you're getting more features and also a better memory controller. So for example, if you had to pick between like the Z590 and the B550, the 590 will probably support higher RAM speeds and like more bandwidth, larger RAM, maybe dual, maybe quad channel, something like that. And also just the prefix also just indicates like, with Z and X having more USB ports, better like Ethernet support, Wi-Fi, all that stuff. And then also, so most brands will have their own like Wi-Fi denotation. So like, just for example, AORS has like AX if it like supports Wi-Fi. And other companies just like that. And then most companies have their own kind of like product line or product brands within all their motherboards. So for example, MSI has the Pro series. So you'll see a bunch of MSI motherboards that are going to be Pros. And then AORS has, for example, Gigabyte has AORS, which is like a line of motherboards that Gigabyte sells. And so, yeah, you just want to be looking at like reviews for that product line, reviews for that specific one, and matching like the prefix with like the quality you want, where Z again and X being the best, and obviously making sure that you match which brand you're going for with Intel and AMD. So yeah, that's a look at the motherboard market. So yeah, like I already kind of talked about this, but my advice, but Wi-Fi or Ethernet is recommended. Match your build performance tier. I'm gonna say this again. So don't buy a very expensive CPU and GPU just to get like a $50 motherboard. That is just the worst thing you can do, because the motherboard really is like the chassis and the base of your computer, and you're gonna want to match the quality of your other components. So like we talked about for CPU, you want to get the adequate VRMs and get that adequate tiering for performance. And then for like your storage and GPU, you want to match that with the PCIe generation and the number of lanes and stuff like that. And then for RAM, you want to match that with memory controller. So we didn't explicitly talk about this because every motherboard is kind of different, but you can look at your motherboard's website and like see what their memory controller is, how much RAM they support, how many gigabytes, the speed, the bandwidth, stuff like that, and make sure that your RAM matches that, because you don't want to be bottlenecked by your motherboard. And then lastly, all motherboards will push their innovative heat sinks and their like next gen BIOS, but those usually don't really mean anything. So like certainly don't buy a motherboard because you're like, oh, they have a really innovative heat sink. Like that's probably just like kind of BS. And so you can brush past all that and get to the real specs, which are like the stuff we talked about. Okay, so next up we have the power supply unit. So this is a pretty easy component to go over because there's not a ton of specs that are really that important, and for the most part you just want to just get a reliable power supply unit that does its job and nothing really more. So obviously the most important one is just power, right? Your computer, when you add up all the components, might take 750 watts, and so you need to provide that much power from your power supply. So each power supply is going to be rated for a certain amount of watts, and obviously you want to pick one that will provide at least enough power to power all your components. Then we've got the 80 plus rating. So this is an efficiency rating, and they're usually marked by these titles like bronze, silver, gold, or titanium. And so basically this denotes how efficient the power supply is. So like a really high-end power supply that has a really good 80 plus rating, like titanium or something, will be very efficient, and that means that it will like not waste any electricity, or waste less electricity I should say, so that you get like more efficiency, so your electrical bill is lower at the end of the month, even though your PC is still using a lot of power. And then modularity is another really important factor. So if you look at these two power supplies right here, these are full modular power supplies. And so what that means is that all of the cables that power the PC, they have ports. So like you can see here, this is the CPU power. And so there's just a port that you plug in a cable to. Same with the motherboard cables here. Same with the SATA cables. You can plug in a cable into this port. And you can plug that in. You can use the default cable that came with the power supply, or you could buy your own custom cable. For semi or for none, specifically for not modular power supply units, there's no ports here. There's just a cable that comes directly out of it. So you couldn't replace the cable. And so the reason why this could be important is that if you're doing a really large build, maybe the cables that come with the power supply aren't long enough to reach your motherboard if your configuration is a little weird. And so you would need to have a modular motherboard or modular power supply so you could replace that with a longer cable. But if you don't have a modular power supply, then you're kind of out of luck because these cables are like directly mounted into the power supply, so you can't change them. So, modularity is kind of a convenience. I wouldn't say it's that important if it's like that much more money, but usually it's just like an additional little factor. And usually if you're already getting a good power supply that has a high power rating and a good 80 plus rating, it will probably just be modular. So this is probably the last thing you want to consider. So the market, I didn't want to talk about the market just because it's pretty much just a couple companies like Thermalite, Corsair, Cooling Master, and they're not really that distinguishable each. Like, people will have their arguments over which one's better, but for the most part, the power supply just does its job, and that's all you need to worry about. So yeah, just look at reviews and stuff. My advice is basically that all categories like gamers, content creators, and developers, they all need a good PSU. So don't skimp out on this for sure, because you don't want this to be the thing that holds your build back. And if you do really care about the electrical bills, then definitely go for that 80 plus rating, because that will probably save you money in the long term. And yeah, don't scrape by the power rating. So if you add up all your components and add up all the TDPs of each component, and you see that you're going to draw like, say, 640 watts, don't just get a 650 watt power supply, because it's just not worth the risk of scraping by. It's more reliable to just go for like the next step up, like the 700 or the 750 watt power supply, just so that you're on the safe side. All right, the last component we have to go over is case and case fans. So just like the power supply, this should be pretty straightforward, and I'm not going to go into super detail on the case because it doesn't really affect performance that much, and you mostly just need to focus on getting compatibility to work and everything like that. So I'm only going to cover those topics, but you can really get into style here if that's what you're going for. So for the main driving factor of the case, it's just form factor. So there's full tower is like the largest, and then mid tower is like your average case, and then mini tower is if you're running like a smaller motherboard. So like an ATX board will fit into either of these, but then you probably want to get a mini ATX for some of these smaller towers and stuff like that. So yeah, just check your motherboard's compatibility with the different size types for MITX, ATX, mini ITX. And then fans are another big topic. So basically there's case fans, and those usually run on the tops, the back, and the front of the computer. So typically you'll always have at least 3 case fans running on the front of the computer. And you can't see them here, but they are behind this panel. And so those bring air into the computer, and then typically you'll have like air being exhausted out the top and the back, and then your power supply will actually have a fan that draws a little bit of air into the computer from the bottom. So the airflow typically goes in from the front and the bottom and out from the top and the back. And so you just want to consider like, okay, do the fans come with this case or do they not? Do I have to buy separate fans? Are the fans that come with it any good? Like, we already talked about fan stats like CFM and stuff like that, like making sure those stats are reliable and will serve the amount of cooling you think you'll need. Other big thing is like cooler options. So here you can see this is, in this case, is a liquid cooler inside, and on top this is actually the radiator. These fans aren't built into the case. These actually come with the cooler, and you can see the cooler tubes are actually going up to this big radiator up here. So some cases wouldn't be able to fit a radiator this big. Some would only be able to fit it in the front. Some maybe only in the back or something like that. So just make sure that based on the cooler you want, if your case can handle that, and where you'd have to move these options. Like, for example, if you were going to put the radiator in the front here, maybe you want to unscrew these fans in the front and then put them in other places on the build, like on the top or the bottom or something like that. So just considering all your cooler options. Obviously just dimensions in general are important, because the GPU and the motherboard and all that have dimensions that need to fit into the case. And we talked about airflow. That's basically just where your air is going. So you want to plan for airflow and recognize that there's other types of airflow too. Like, you could do a style where you have air going in like 3 directions and only exiting the top or something like that. Depends on just what you're going for, and you can look up the different ones and see like what you think is optimal. But I think most builds have in on the front and the bottom and out on the top and the back. And then the main last thing is style. So like I don't really go for style, but if you really want to, you can get into like good RGB and stuff like that and crazy shapes. That's usually going to cost you, but like if that's what you're into, then you can go for that. The one last thing that's like I would say is pretty important is just I/O on the case. So like if you have good front I/O, like sometimes people really want to have a certain number of USB ports or audio jacks or something like that on the top of the case, but that's not super important because you can always just plug it into the motherboard if you want. So if you really do need that front I/O though, obviously you should care about that, and that's always located at the very top of the case, somewhere up here, or sometimes on the front panel, but that's usually pretty rare nowadays. But if you are kind of confused about what I mean by the whole style thing, I did add a slide here just so you can see just how crazy some cases get. Cases are really where the style just goes insane. Like you can see some of these cases, it's like, how does a PC even fit in there? I don't know, but they pull it off. So yeah, that's a whole rabbit hole you can get down, but I'm not going to really cover it here. And then my advice, cases are pretty simple, but one thing I would say is removable filters are a really good thing to get, I would say. Like I have them for my PC right now. Basically, just any case where you can slide out the filter, or at least cases where there is a filter. And this just at least makes it so that you can prevent dust from getting into that PC, ruining the GPU, ruining the CPU over time, and just clogging up your fans and making it so you have to get new fans. So having removable filters is really good. I know like one example is like the Meshify Compact, I believe, has some removable filters, and there's some other cases you just need to check and make sure if that has it or not. It's not a must, but it is definitely good for the longevity of your PC components. And then, case, I didn't do manufacturers for cases because, there's a bunch of different manufacturers and none of them are super distinguishable. But, just check reviews for the case you're going to get. Like I said before, like if there's no reviews and there's, no YouTube like unboxing and stuff like that, then maybe there's a reason why that is. Like you probably want to get a case that's at least somewhat reviewed. Obviously check dimensions for all the parts. The main considerations being GPU length and width, CPU cooler height and clearance, like on all different sides. And if you have a CPU liquid cooler, the thickness of the radiator and the length of the radiator and where that can fit. Like if you can put a 3 fan wide radiator or only like a 2 fan wide radiator in different places. And obviously just the motherboard size are the main dimensions. And the other thing I'd recommend, and I would honestly recommend this for all the parts that you look to buy, but a lot, especially for like the case and the motherboard, and that is read the manual before you even buy it. Like read the manual that you can download off their website, because usually this will tell you the installation guide, and I've found that sometimes there's details in the manual itself that I feel like you should definitely know before you even buy the product, because it will tell you things like, oh, you actually can't insert like this type of drive into this computer or something like that. I don't know, just weird things about it. And especially they usually have a way more detailed breakdown of where you can put liquid coolers. So yeah, I would definitely do that. So yeah, other than that, though, like I said before, like cases are kind of just, they just need to be serviceable and reliable and house your PC and protect it against the elements. Okay, so now that we have a really good understanding of every component and how the market is broken down and the important specs that you need to think about, we're in a really good place now. And so now I'm finally going to explain my method that I think will be a really good way for you to break down how to go about picking parts for your PC. So it's a 10-step method, and the goal of this method is that it will work across all use cases, and specifically the big 3 categories we talked about. I want it to be time independent, so it shouldn't matter whether you're watching this video in 2024 or even 2030, who knows. This method should still be solid, and the method really hinges on 2 parts, specification and selection. So in specification, you're going to pick important stats that you need to have for your component, but you're not actually going to pick the specific part itself. You're just going to specify the stats you need. And then selection, you're actually going to select the individual model that you're actually going to buy. And I also wanted to mention that you should really use PCPartPicker.com. It's a great website where you can build your selection of parts all at once, and you can visualize it so that you don't have to be writing stuff down. And PC Part Picker also does some really helpful things, like it calculates the total power that you're using and other stuff like that, like compatibility issues. So, this method is best paired with like also putting your parts into PC Part Picker. And then after the method, I'm just going to give you some current market advice based on how things are shaping up right now. Let's get into the method. So, step number 1, CPU and GPU selection. So, there's no specification for this. You're going right to selection. And the reason is because the CPU and GPU really mark the core performance of your computer. So, these are the first thing that you want to select. And remember, you want to look at budget, use case are the two main things you want to care about, because typically you're going to set a budget for your entire computer, like anywhere between $1,000 to $2,000, and so your GPU and CPU combined should be roughly 40 to 70% of your budget. So on really high-end PCs, you're going to be leaning more towards like 70% of the budget, whereas on really low-end PCs, maybe these only combine to say 40% of the budget. And then for use case, we already talked about this, but if you're a programmer or a developer or a creator, maybe you want a better CPU, and if you're a gamer, you want a better GPU. So you can decide how you want to split those two, and it could be as low as the CPU can only be 10%, the GPU could be like 60% of the cost. But you want to pick that, and compare the brands like what we talked about. If you're getting a higher end budget, go with NVIDIA probably as of right now. Go with the higher end CPUs, but if you're getting low budget, maybe AMD is a smarter GPU, and go with the lower series CPUs. Now, the reason I'm not getting too specific on the specs here is because the thing I would recommend is just benchmark. So there's softwares like PC Benchmark and Tom's Hardware, not softwares, but websites that have great benchmarking reviews for all types of CPUs and GPUs. So definitely look at the stats and compare stats and figure out, what GPU or CPU you think is better. But really at the end of the day, when you think you've found a good CPU, look it up in Tom's Hardware, look it up in PC Benchmark, compare it to your other options in the same price range, and then from there pick the optimal one, because the benchmark is the most important thing, and especially if you can find target software benchmarks. So this means like if you are buying this PC because you really want to play Valorant, like try to find some Valorant benchmarks for this specific component, because that will give you really, really good information on what you can expect for frame rate and stuff like that. Or if you're a creator, Blender has like a website where they have all their benchmarks for different types of GPUs, and other softwares will tell you like, this is a good GPU or CPU to get, because that's really what you want to end up caring about, because that's what you're going to use. So really it is a lot more about looking at the benchmarks for these two components, because that's kind of what they're defined by. And then also just reviews and builds. So look up, reviews on this product, find the caveats, because there's always going to be some downside to the product. So make sure you know that. Don't think that you're getting a product that has no drawbacks. And that drawback might just be that it's just very expensive, So it could not feel like it has any drawbacks, but it is just very expensive. And then, look at other builds. So PCPartPicker.com has a section of completed builds that you can just go through. So look up your part in other completed builds. And, maybe the person will say, like, I actually shouldn't have got this part, or this part worked out really well for this build. If you're not finding your part in any builds, then that could be alarming. That could be a red flag, because, if you're thinking this part looks sweet, but no one else has put it into their build, then, you probably didn't make a good discovery. You probably just don't know about some really bad factors of that part. So, do all your research for those. And really, like I said, it really is just about benchmarking and use cases that you want to look into, and that percentage of your budget. So those two kind of really pin down the feel of the build. So pick those two parts. And then step 2 is RAM specification. So after you've selected the GPU and CPU, you're going to specify 3 important stats that you want out of your RAM. And those are going to be the DDR version, the size, and the number of channels. And like we said, channels is typically just going to be dual rank. You're probably, unless you really like know what you're doing, you're probably just going to do dual rank channels. For size, we talked about that, how gamers probably want 16 or maybe even fewer gigabytes of RAM, whereas content creators and developers maybe want 32 gigabytes or even up to 64. They're probably still fine with 16, but just more RAM will be better for them. And then DDR version is about speed and performance. So, gamers are going to want that increased clock speed. They're going to want that lower latency. Content creators aren't going to care about that as much. But so I want you to write down exactly what you want out of these 3 stats. And just like save that away, keep that, because that's really important that you already come up with that specification now. And so some factors to consider are just use case, CPU specs, because again, the goal is that we already pin down the exact CPU that we are going to buy. So look at the specs on that CPU and see the limiting factors for these numbers, right? And then budget obviously is a big factor too. The price point, like, if your build is only $1,000 build, don't be looking at like DDR5, like 64 gigabytes, something like that. That's just unrealistic. So consider the budget in all these, and then pick like these values, write them down, and save them so that you know exactly what kind of specs you're looking for in your RAM. All right, next, number 3, storage specification. So there's 3 important specs again that you want to specify for storage, and that is the form factor. So if you are going to do an M.2 drive or a SATA drive, the PCIe generation. So are you going to do Gen 5 or are you going to just be okay with Gen 4? And the size and the number of devices. So are you going to have one drive that's just stores everything? Are you going to have 2 or maybe even 3 or 4 drives? What are they? Are they all going to be M.2? Are they all going to be SATA? What are going to be the generations for the PCIe lanes on those drives? So just, again, pick these numbers, write them down and save them. And the factors that usually come into there are very similar to before. It's mostly just going to be budget, CPU compatibility, and use case. So again, it's also good to like look at reviews, but like I said, storage is mostly reliable. Like the brand differentiation is relatively low. So pretty much any 250 gig SSD will probably behave pretty similarly. It doesn't matter whether it was from WD Blue or Sabrent Rocket or any of those different brands. You're probably going to be fine with just going off of these main stats. So pick these stats first, but don't pick a specific storage yet. This is just the specification stage, right? So number 4 is motherboard specification, and I put here minimum. So you're going to specify the form factor. Remember, that's eATX, ATX Mini, or Mini ITX. You're going to specify the I/O support. So at a minimum, that's why I put minimum, you need like a minimum of say 2 USBs for like your keyboard and mouse or something like that. You're going to specify a network support. So do you want just Ethernet? Do you want Ethernet and Wi-Fi? Are you going to get a separate card so you don't need any of those? And then audio codec. So we talked about that as well. Do you care about having a good audio codec, or are you okay with a bad one? So just write down your minimum specs for these, and also consider, and you should really write down all of the inherited specs. So you're going to inherit what type of CPU socket you're gonna need for your motherboard, because you already selected your CPU. You're going to inherit the RAM DDR version because you already specified the RAM DDR version from the RAM specification. So that's important also for what type of motherboard you can get. Same with RAM channels, and same with PCIe lanes, because we already selected our GPU and we already specified our storage. So those two will contribute to the number of PCIe lanes. So you want to write down how many PCIe lanes you need at a minimum, right? So now that we've specified all the key things we need for our motherboard, we will move right on to motherboard selection. So I separated these just because it really is important to just consider the minimums and the inherited specs you need. So once you write all these down, you can just go through motherboard to motherboard and just look at the specs, check if they line up. If they don't, discard it. So now motherboard selection, step 5. Just consider budget. Obviously, consider all the previous specs that you need to hit because you need to hit those, right? But so consider budget. More VRMs is better because that was that CPU performance we talked about. Obviously, consider use case, like if the motherboard has 5 M.2 sticks and it markets itself as a creator thing because there's a lot of storage and you're a gamer, you probably don't need that, right? Reviews are big. Make sure, like, look at builds and stuff like that. And if you're not finding that anyone on PC Benchmark has built a build with your motherboard, that's kind of a red flag again. And if people are all saying like it has a problem, you want to just be aware of that. Again, special features. This might be a selling point. Like if you really want Q Flash or one of those cool features that a motherboard has, know about that. Drawbacks. So every motherboard has a drawback. That's just the way it is. So definitely be aware of your motherboard's drawback. And it might just be like, maybe it has a horrible audio codec. Maybe it doesn't support PCIe Gen 5 or whatever. Maybe it's just really pricey for the tier that it's in, So be aware of all of those types of drawbacks because it is really important to make sure that you're not just thinking your motherboard is just the best and that it has no problems with it. So brand matching is also maybe a consideration. I put this kind of more on the bottom of the list because it's not that big of a deal. But make sure that, like, if you want to do brand matching, like for example, MSI I believe has like a cool software where if you have an MSI motherboard and an MSI GPU, that motherboard can like detect the GPU and like do some cool stuff with that. So maybe you want brand matching. CPU compatibility on motherboard website. This is important. So you can have a compatible CPU just by socket type, but also definitely look on the motherboard website. To make sure that part is completely compatible with the CPU you're planning on buying because you already selected that CPU. And motherboards typically 10 to 20% of budget. So on a low-end build, it's probably going to be like 20%. On a high-end build, it might be more like 10%. It kind of varies. The idea here is just that if you have an insanely expensive, like say you have like a $2,000 GPU, then your motherboard won't increase that much so your motherboard may only be like $200 or $300. Whereas on a low end build, you still are going to have like say a $100 motherboard. But typically somewhere between $100 and $300 is the price you'll be paying for a motherboard. All right, 6 is RAM selection. So now that we selected the motherboard, we're going to go back and select the RAM. And the reason I do it in this order is because you want to select the motherboard is kind of more important than the RAM brand, but different RAM brands are compatible with different motherboards. So some considerations here are, well, the main consideration is just motherboard compatibility. So on your motherboard's website, there will typically be a big sheet and you can search through, and you can search a RAM type up, search like a brand of RAM up and that specific model, and it'll tell you whether it's compatible or not. So, and it'll also tell you like how many gigabytes it's compatible and the number of channels and stuff like that. So use this heavily to look for your RAM. And then also obviously consider budget, speed, use case. Reviews are pretty important. I already told you guys how like RAM is not very differentiated. So RAM by Corsair, if it has all the same specs as RAM by, I don't know, a G-Skill, is probably not going to be totally different. You're not going to like notice a major performance difference. But, reviews are still important, obviously, because there can be some really bad RAM out there. So do look at reviews. The heatsink is like kind of at the bottom of the list, but so RAM has a heatsink and that increases longevity and performance a little bit. So consider, different RAM brands. That's the way they distinguish themselves for the most part, is having better heat sinks. And RAM is typically going to be 2 to 10% of your budget, where for higher end builds, RAM is probably going to be a lower percent of your budget because it's going to be dwarfed by the really expensive GPU and CPU. But for lower end builds, it might be a higher percentage, but also just, typically you're matching the price anyway. So like a $1,000 build might only have like $50 RAM sticks because you're only using say like 8 or 16 gigabytes, whereas like a really nice like $2,000 plus build will start to get into like the $100 or all the way up to like $200, even $300 or $400 for RAM, and so you're really going to be paying for that. Speed is the big thing, and size obviously is the big thing, but you already specified those stats. So next up, you're going to finally go to storage. So storage is saved for the end because storage selection is pretty minimal in terms of components, because you basically are just going to look up motherboard compatibility. So they'll also have a compatibility section for storage or known builds. I asterisk this because, like, for example, the PC I'm literally working on right now, my SSD wasn't on the motherboard compatibility sheet, but I knew it was compatible from like other builds I had seen that used it. So I bought it anyway because, most storage devices are still going to be compatible with your motherboard, even if it doesn't specifically say they're compatible. But obviously, just caution. I don't want to be the one that told you it is compatible, but it's not. So I would try to find at least the motherboard saying that this storage device is compatible, or that you've seen known builds that have that device and that motherboard, and it works fine. Next, obviously, is budget, and typically that's going to be 5 to 10% of your budget. Usually, like a good SSD, like say a terabyte SSD, is probably going to be around $100 to $150, currently at least right now. Look at reviews, look at rewrite speeds, look at endurance. People in reviews are going to tell you these things. They're going to say, oh, this is a blazing fast SSD, or, this SSD is slow but reliable, stuff like that. So, just consider all these. You don't really have to do too much research for the storage selection, because again, it mostly is just going to be driven off of the specification that we made earlier. But again, make sure you're hitting all the specs that you already specified before you go to this step, because this step will really then just be driven by motherboard compatibility. So now onto the non-performance components. So CPU cooler selection. We're just going to go right to selection. There's no specification because you really are just making sure that you match all the previous specs. So matching the budget, like we talked about, for liquid coolers for higher budget, air for lower budget, and matching the CPU socket compatibility, matching size compatibility, making sure that the cooler doesn't obstruct the RAM or anything like that. And really, known builds are really helpful for this. Like, you're not going to get every little dimension on this cooler, but if you can find a known build with that cooler and that motherboard, and you can see that that cooler isn't obstructing the RAM or anything like that, then you're probably safe to assume that it's compatible. And obviously CPU socket size. Just make sure it says that it's the same socket size as your CPU. And cooler reviews are really big. So coolers don't have a ton of good differentiating specs, but like if you go on Gamer's Nexus channel, he does a ton of cooler reviews, and they're so good. Like, I definitely recommend watching his cooler review for the coolers you're looking at getting. And if he doesn't have a review, then maybe that cooler's not so good. So like, I'd be alarmed if he doesn't have a review, because he reviews most of like the really good coolers. So just check that out. Check out other people's reviews, because you really want to make sure that you're not getting some sketch cooler, because there's not a ton of specs to differentiate them. Look at benchmarks. Typically in like degrees, you'll see like, oh, this is this benchmark where we maxed out like a Intel i5 CPU and it kept the CPU at 52 degrees or something like that. Benchmarks will be like that. And then known builds, obviously, for specs and compatibility. And typically that'll run to between 5 to 10% of your budget, with 5% being for really high-end builds, because the cooler price is dwarfed by the big CPU and GPU price. But for low-end builds, you're going to have this be a little bit more, a higher percentage of your budget, just because your CPU and GPU don't really cost that much. All right, almost done. Number 9 is power supply selection. So we can go straight to selection for this, because basically we've now picked all of the parts that require electricity in the build. So we can just calculate the total power, and this is automatically calculated for you by PC Part Picker if you're using that. Or you can just do it by hand by looking up the TDP for each of your components in their manufacturer's spec sheet and figure out, like, okay, is this drawing 743 watts of power? Is this drawing 500 watts of power? Just figure out that number. And then, you're going to want to buy the power supply that is in that range of power. So a power supply usually will say, oh, I'm a 850 watt power supply. I'm a 750 watt, 650 watt, something like that. And don't buy like right up. Like if you calculate it and you're at like $643, don't buy a 650 power supply. Just buy a 750. Buy like a good 100 over maybe, just to be safe, I would say. I've never had experience with riding the line, but I know people say that's like not a good thing to do. So don't get some power that's like just above your calculated max power. Get a good buffer of at least like 50 or 100 watts just to be safe. And then select your 80 plus rating. So this determines how power efficient your power supply is. So a good 80 plus rating, like the gold or titanium, will mean that it's really power efficient and like it'll last a good long time and stuff like that. So just budget match for that. Like, don't buy like the most expensive power supply if your computer is only like $900. And then typically this runs between 5 and 15% of your budget. So yeah. Last step number 10 is, like you guys probably expected, case selection. So now you've selected pretty much every part that's going to be inside your PC, and you just need to select the case. So obviously the big drivers here are form factor, so what motherboard you're selecting, what CPU cooler, the length of the GPU. Those are the main things, because the GPU length is important because you can get a really small case, but if your GPU is like the 4090, it might be actually too short of a case, and the GPU might be protruding it and not really fit into the case. CPU cooler, we talked about CPU cooler. You don't want it to stick out of the end of your case, so you can't put the glass on. And motherboard, obviously, every case will say it's a like eATX or ATX or mini ATX, or sorry, micro ATX or mini ATX. It'll specify which motherboard form factor is kind of primarily designed for that case. Front I/O support, so you already selected your motherboard, so go ahead and look at that motherboard's like I/O breakout that it has for front I/O, and make sure you're matching that if you want to. Like if you really want to have USB-C out on the front I/O, if you really want to have an audio jack on front I/O, power button, reset button, stuff like that. Case fans are important, so does the case come with fans? Are they good fans? Are you gonna have to buy separate fans? Just look at all that. Look at how many fans you need. You do want to have at least you want to have 3 case fans here and usually 1 in the back at least at a minimum. So look at all those. Style, if you care about that. I don't, so I didn't really talk about much in this video, but do you want all the RGBs to light up and have like your cool build, flash different colors? And typically a case can be anywhere from 2 to 15% of your budget. So just a really wide range of different options you can have. If you really want to go all out, you can. Don't get like the cheapest case ever, because there can be some important downsides. Like if the case just isn't very sturdy, if it's made out of a cheap thin metal or something like that, that would probably be a reason not to get like the cheapest case. And also you want to consider things like airflow, right? Because you don't want to get the absolute cheapest case that has like horrible airflow and is like making your PC super hot. So that is the method. So here's just a overview of everything we did basically. And again, the main importance of this method is the order. So just that you do it in this order, I think will allow you to have the best kind of guided step-by-step selection process, and it'll allow you to choose components just in the right order of priority and of kind of specification, because a lot of the specs of one component will then kind of drive the selection of the other component. So yeah, this is just the overall 10-step method all on one page, so you can pause or screenshot this or whatever to write stuff down. So yeah, on to the advice. All right, great. So that was the method, and hopefully you can follow that method. It gives you a nice order to pick your parts in, and at the end of that you can come out with a really clean looking build. And if you get to any step and you realize a problem, like say you specified a DDR version and then you found out later when you actually went to selection that it was too pricey, just go back and reiterate, but like make sure you still follow the order when you're reiterating. Like if you go back to step 3, you have to redo step 4 and 5 because they're each step affects the next step. So hopefully that method will be really solid for you guys to choose your PC parts. So my current and market advice for right now, so currently it is January 2023, and some things I wanted to mention are DDR5, it's too early. That might be tough for people to hear, but I think it's too early. Mostly just because, like, currently with our 5,000 mega transfer per second DDR5 sticks, their cast latency is really high, and so their total speed, their effective speed, is really not that much faster than top end DDR4 sticks, which have a lower speed, but a also a lower latency. So they have like roughly the same effective speed. Also, even if you do want to future-proof your build, so say you're thinking, oh, I'm going to get DDR5 because in 2 years I'm going to buy new DDR5 sticks that are even faster. I would also caution you there because the CPU is memory speed specific. So if you're thinking you're going to upgrade, well, take a look at that CPU. It probably only supports up to like 5,000 megatransfers per second anyway. So if you were going to upgrade to like a 7,000 megatransfers per second DDR5 stick, you're probably also going to need to upgrade your CPU to get any noticeable effect out of that. So, are you really going to get DDR5 just to have to upgrade your CPU and RAM? And then if you upgrade your CPU with a newer CPU, what if that CPU isn't even compatible with your old motherboard, right? Like it's a different socket type or something. So there's a lot of considerations there. Right, I didn't get DDR5 in my recent build. I got DDR4. So I would recommend, I just don't recommend it to people. But if you really want to, if that's your thing, then go for it. You probably will see a little bit more performance, but right now it's just expensive and it's not performant enough that I would recommend it to anyone. Intel CPUs are winning at the top right now. It kind of flip-flops every once in a while, but so currently like the i7s and i9s and like the 12th and 13th gen are usually beating their AMD counterparts at the price points they're at. So that's just my advice for the top. For the middle sections and lower sections, it kind of mixes and flip-flops, but generally I think Intel is winning right now. NVIDIA is winning at the top for GPUs, but AMD is controlling the lower budget, and it looks like it's strange, but so NVIDIA just released their 4000 series with the 4080 and the 4090, and they're not even making lower tier GPUs, it looks like, anymore. So I think NVIDIA is really specializing in just really high-end GPUs, but AMD is starting to really take over all the lower budget GPUs. So match your price budget with that. And also take an important note, GPUs really aren't even supporting PCIe Gen 5 yet. So if your motherboard says Gen 5 PCIe for the GPU port, check your GPU. It probably doesn't even support Gen 5. So like, are you shelling out an extra $20 for that? Like, it's not worth it, right? And then I kind of already talked about this, but getting a small, fast M.2 plus a larger 2.5-inch SSD is kind of a play for like saving money while not compromising on speed and storage size. Another cool thing is cooler mounting adapters. So you can get a CPU cooler that's maybe like cheaper or something like that, and it doesn't say it supports your CPU socket out of the box, but you can find a mounting adapter that will configure that to support your different CPU, and maybe you can use that to get the cooler you really wanted but just wasn't compatible or something like that. And then I would say right now Newegg and Amazon are kind of the best retailers. They're both like really reliable, fast shipping, and carry the most stuff. But also, if you're near a Micro Center, which is pretty much the only brick and mortar store that sells PC parts, Micro Center's the bomb. So unfortunately, there's none near me. But if you are near a Micro Center, you will find good deals usually and great customer service there. So that's like really the only brick and mortar PC stores. And yeah, there's a couple other manufacturers or a couple other retailers like B&H, people like those that you can go to, but I think Newegg and Amazon are going to be the two big ones. So yeah, that concludes this video. Man, we covered a lot, but hopefully now you have a really, really good idea of how exactly you're going to go through selecting parts for your build. And I have confidence that with this method, you'll be able to build a really good PC, and you'll really optimize every dollar you put into it, and you'll get exactly what you want for your use case. So I hope you enjoyed this video. I hope you stayed through it and learned a lot, and I hope you build a successful PC. So see you guys in the next video.